start. These warm-ups are just to start jogging our brains. In the first one, if you haven't done it already, natural log is another way to express log base e of e to the x equals 4. Log base e of e undo each other. X is 4. Common log of 10 to the x plus 1 power. Well, we assume common log is base 10 every single time. If we do not see a base, we write in base 10. Log base 10 of 10 undo each other. X plus 1 is 3. Therefore, x is 2. So, in the next warm-up, we have log base 5 on both sides by themselves. So, therefore, I'm going to raise each side to be an exponent of 5. We called that exponentiate last week. Raise each side to be an exponent of 5. When this happens, log base 5 of 5 undo each other. Now, it's at this point where we get x plus 2 equals x squared. We got to jog our memories till last semester of how, okay, so this will never go away. These sort of little problems will never go away. You get everything to one side and you got to ask yourself, do I want to do quadratic formula or factor? Factoring is going to be the faster way. So get everything to one side. And then we're checking 2 or negative 1. If I plug in 2, log base 5 of 2 plus 2, so that's log base 5 of 4 on the left. If you took 2 squared, that's 4, so log base 5 of another 4. 2 checks out, that's one of my solutions. If I tried negative 1, log base 5 of negative 1 plus 2 to 1. So log base 5 of 1, is that going to be the same as, okay, negative 1 squared is 1, log base 5 of 1. So they both check. So this is on the back page of your guided notes. So those of you who were not with us last Friday, example 10, very last page of notes. See if you can remember how to start this. So, raising each side, we're going to exponentiate immediately. We have log base 4 of something equal to a number. Our only option is to exponentiate both sides to be a power of 4. So 4 to the log base 4 undo each other. We're left with x plus 3 equals 16. We got to check to see if x actually does equal 30. So here we go. Checking log base 4 of 13 plus 3. Is that going to be the same as 2 is our question in our head. So log base 4 of 16, does that come out to be 2? So we ask ourselves, okay, 4 to what power gets us 16? 2. It is 2. So it does check out. 13 is our answer. We cannot exponentiate immediately. In order to exponentiate, we're going to need one logarithm on a side by itself. That's the only reason why we do it. So you got to ask yourself, what are our options? So we've got to figure out how can we condense these together. Our gut reaction is to add the arguments. But what do we do with powers? What are bases doing when you're adding the powers? So when we add powers, what are the bases doing? Hold on. So when we're adding the powers, we're going to multiply the arguments. We're going to multiply the arguments. Multiply the arguments. So it's not 6x. Technically, it's going to be log of 5x times x. When we're adding a logarithm of the same base, we're going to multiply the arguments when we condense. And then we'll figure out what are we going to do with that minus 1. I'm going to, instead of looking at this as 5x times x, I'm going to look at it as 5x squared. And then add 1 to the other side. So it's not until now when we have a condensed logarithm on one side where we can exponentiate. Raise each side to be an exponent. So make each side be an exponent of 10. So log to the common log base 10, undo each other. We're left with 5x squared equals 1,000, and so on. So we're going to check to see if positive 10 root 2 or if negative 10 root 2 both work. The way we're going to do this is, well, we could try to either use our calculator or our knowledge. We're going to take common log of 5 times 10 root 2 plus common log 10 root 2. And then we'll subtract 1 to see if it's going to equal 2. So negative 10 root 2, we've got to see if it checks out. So when you try to plug this into your calculator to check the answer, since we have such a weird answer, we get domain error, which should be legit. We cannot take a logarithm of a negative number. And this middle piece, well actually even this piece, when you take a positive times a negative, you get a negative number. It doesn't work. We've got a vertical line as an asymptote for a reason. It cuts off the domain somewhere. So we've got to be aware that not all answers are going to work. Only the positive answer, positive 10 root 2 is the answer. That's it. So, positive 10 root 2 is the only answer. All right, moving to the next. So in the next problem, similar stuff. We're going to have to condense log base 2. It's at this point. It's not until you have condensed into a single logarithm on one side that we can exponentiate. 2 to the log base 2 undo each other, and we're down to a quadratic equation. Everything needs to be brought to one side, factored, and so on. Once we break it down, we've got to test both answers. Like we saw before, one of them could work and only work. Both of them could work. None of them, neither of them could work. So let's check x equals 8 first. Taking log base 2 of 8. We're going to ask ourselves, is it 3?
Yeah, wouldn't it have to be 3 plus 0? Because wouldn't that equal 0?
So log base 2 of 1, 2 to what power gets you 1? 0. Yeah. So 3 plus 0, 8 is one of our solutions. We got to see if we have 2 solutions. So we're going to check if negative 1 works. So when we plug in negative 1, 2 to what power gets us negative 1? Because of this, it does not fit our domain. Can't be a solution. We only have one solution in this problem, and it's 8. It is 8. Now, notice how ironic that the previous example we crossed out the negative solution, and this problem we crossed out the negative solution. That is ironic. That is not the rule. It's not going to always happen every time, because look back at our warm-up. Our warm-up had 2 solutions, and one of them was negative, and it checks. The negative checks.
Just depends on where the variable is in the equation.
Yeah. Is it by itself or what?
Is it going to be the power to the base or what? Because when it becomes the power to the base, you got to find yourself a positive number or whatever.
Right. Okay.